Hey, chemistry, here we go with our Unit 3 review. In this unit, we learned four big things: how to name and write type 1 binary ionic compounds, type 2 binary ionic compounds with polyatomic ions, and covalent compounds. The most important resources that you're going to need are, of course, your reference sheet, but also this graphic that we received during Unit 3, which shows us the relative charges of groups 1 and 2, the charges of aluminum, zinc, and silver, as well as the charges of nonmetals in groups 16, 17, and 15. So let's start with type 1 binary ionic compounds. Whenever we are talking about an ionic compound, we are generally talking about a metal and a nonmetal. Remember, metals always have positive charges and nonmetals have negative charges when we're talking about ionic compounds. We call them type 1 because they can only form one type of cation, which means the metal can only have one type of charge. So that would be all of the metals in group 1, all of the metals in group 2, aluminum, zinc, and silver. Everything else is considered a type 2 binary ionic compound, which we'll talk about momentarily. You will have really two types of problems that will involve type 1 binary ionic compounds, and that is going from their name to their formula or from their formula to their name. In order to go from their name to their formula, you're going to need to understand how their charges to figure out how many of each element there are. So aluminum, we know, shows up as one of our special elements, which has a charge of positive 3. The way I would write this is I would just put plus 3 above aluminum. Next, iodide is the type 1 binary ionic compound way of saying iodine, which shows up in group 17 or 7A, which has a charge of minus 1. So I'm going to put minus 1 above iodine. To think about balancing these charges, one aluminum has a charge of positive 3. One iodine only has a charge of negative 1. And as always, our goal is to have a charge of 0 to balance out those charges and become neutral. So that means that if I want to balance out aluminum's charge of plus 3, I'm going to need 3 iodines with a charge of minus 1 to give me an overall charge of 0. This gives me a clue as to how I would write the formula for it. I would put Al, because there's only one aluminum, and then I with a subscript of 3 telling me I needed 3 iodines to balance out my 1 aluminum. Going from the formula to the name is much easier. We're always going to start with just the name of the first element, that is calcium, and then the second element, but it needs to end in IDE. The only way to get good at these is to keep practicing with them. The way you would read this would be calcium bromide, but that will be true with all of the nonmetals. So fluoride, chloride, bromide, iodide, oxide, sulfide, selenide, nitride, and phosphide. That's how you would say all of those. Understanding type 2 binary ionic compounds is just as easy. The only difference is we're now using metals that can form more than one cation, which means that they can have multiple possible charges. That is why, if you'll notice in this graphic here, there are no charges listed for most of our D block and F block metals, except for, again, aluminum, zinc, and silver. That's because these metals can have more than one charge. So whereas aluminum always has a charge of plus 3, iron can have different charges, a charge of plus 2, a charge of plus 3, or even a charge of plus 4. Again, you will need to be able to go from formula to name, but that process is relatively easy. Instead, what I really wanted to go over is how to go from name to formula. The nice thing about going from name to formula is that you just need to look at the Roman numeral next to your metal to know its charge. So copper 1 means that copper has a charge of plus 1, but oxygen in our periodic table is in group 16, which has a charge of minus 2. So to balance this out, we would need 2 coppers to balance out 1 oxygen. However, if it was copper 2, now copper has a charge of plus 2. Oxygen still has a charge of minus 2. Remember, our nonmetals have a fixed charge. So writing this one is fairly simple. We just need 1 copper to balance our 1 oxygen. The same thing is true with lead. If it's lead 2, that means lead has a charge of +2, whereas chlorine shows up in group 17 or 7A, so it has a charge of -1. In order to balance out chlorine's charge of -1 and lead's charge of +2, we're going to need 2 chlorines to cancel out that charge from lead. If it was lead 4, lead now has a charge of +4, and chlorine still has a charge of -1, so that would mean I would need 4 chlorines to balance out my 1 lead. If you look at this, you may notice a pattern here. If the charges are different, the subscripts are just flipped. So oxygen has a charge of -2, copper has a charge of 1, so I need 1 oxygen and 2 coppers. The charges in the subscripts effectively flip. In the last example, chloride or chlorine had a charge of 1, lead had a charge of 4, but lead gets the subscript 1 and chlorine gets the subscript 4 to balance the 2 out. If that's confusing you, then just go ahead and write it out the way I've got it. But if you feel like you got that and you want a shortcut for the exam, you can just flip those numbers and you'll get the right amount. Polyatomic ions comes from the word polyatomic, poly meaning many and atomic meaning atoms. These are ions with 1 charge, so you can think of them as type 1 compounds in that they have only 1 charge, but they're made out of multiple atoms. So for example, acetate, which can be written in 2 ways, C2H3O2 or CH3COO, doesn't matter how you write it, and it means the same thing. Acetate, if you were to put all of those elements together, you get a charge of -1. Ammonium, if you were to put 1 nitrogen and 4 hydrogens together, you get a charge of +1. Carbonate is CO3, and that has a charge of 2-, and so on. You will be allowed to use this part of your reference sheet during the common assessment, so you don't have to memorize the charges, but what you do need to recognize is when to go and look up polyatomic ions. Generally, if it ends in ATE or ITE, it is a polyatomic ion, with the exceptions of ammonium, hydroxide, and I think that's it. Oh, and cyanide. Those are the 3 exceptions. All right. Again, just as before, you're going to have to go from compound to formula, and then from the formula to the name. So the process is identical. This iron has a charge of +3 because of those parentheses. It is a type 2 binary ionic compound. Sulfate has a charge of 2-, wrong one, as shown by my polyatomic ions. So that means that if I want to balance these charges out, 1 iron has a charge of +3, 1 sulfate has a charge of -2, and 1 sulfate is made out of 1 sulfur and 4 oxygens, so we don't split those up. If I want to balance these out, I'm going to need couple extra sulfurs here. This gives me a charge of -6, iron, charge of +3. This is a total of +6, a total of -6, for a grand total of 0. The way you write this is very similar to before. The only difference is I'm going to write Fe2 because I needed 2 irons. And then I need to put SO4 in parentheses. Okay, remember SO4 is always stuck together when we're talking about sulfate. It's a package deal. So if I were to say I have 3 sulfates, that means I have 3 SO4s, which is why the 3 goes outside the parentheses and the SO4 goes inside the parentheses. A very similar process with the next one. Calcium is one of our type 1 metals. It shows up in group 2, so it has a charge of +2. Hydroxide is one we're going to need to look up in our polyatomic ion table. Hydroxide has a charge of -1, which means I'm going to need 2 hydroxides to balance 1 calcium. So I'm going to write calcium hydroxide in parentheses with the 2 on the outside. Lastly, going from the formula to the name is relatively simple. If it is a type 1 compound, you're just going to write the name sodium, and then the name of the polyatomic ion, which in this case is carbonate. You can look that up to confirm it. However, if it is a type 2 metal, so like titanium, you're going to need to figure out what its charge is before you turn it into the name. So to do that, I'm going to look at phosphate in the table. Phosphate has a charge of 3 minus, but there's 2 of them. So it's like having 2 3 minuses. However, there are 3 titaniums. So my 3 titaniums have to balance out my 2 phosphates. So that means each titanium has to have a charge of +2. So the way I would write this would be titanium parentheses 2 to show the charge, phosphate. I need to do that with titanium because it is not a type 1 metal. Titanium shows up in the middle of the periodic table, right here in group 4 or 4b. So it does not have a fixed charge. Lastly, we learned how to name and write molecular and covalent compounds. These ones I think are the easy ones because you just need to use the appropriate prefix when you're naming them. The way to tell if it is a molecular or covalent compounds is there are 2 nonmetals. That's the big key. Notice for everything above our ionic compounds, there was a metal and a nonmetal. In covalent or molecular compounds, it's the same thing. It's 2 nonmetals. In order to be successful with these, you will need to memorize the prefixes, though most of them you've probably heard before. Mono meaning 1, di meaning 2, tri meaning 3, and then tetra, penta, hexa, hepta, octa, nona, and deca. You may remember those from when you were doing geometry younger, like a hexagon, a heptagon, an octagon, and so on. So to write the chemical formula, we're just going to look for the prefixes. Nitrogen does not have a prefix, so it's just 1. And then it's trioxide, so that is O3, 3, tri meaning 3. Triphosphorus means that there's 3 phosphoruses, phosphori, something. Hexoxide means that there are 6 oxygens. Hexa is 6. Going the other way, we have 2 phosphoruses, so that would be diphosphorus. The first name always is just as it's written in the periodic table. The second name gets the prefix and then ends in IDE. So 5 is penta, so this would be pentabromide. Just like before, the only way to get good at naming these is to practice them and check them with your teacher. So I encourage you to do that. Nitrogen is all by itself, so I just write nitrogen. And then there are 4 hydrogens. 4 is tetra. So I'm going to write tetrahydride. And that's it. Hopefully this helps with Unit 3. Stay tuned for Unit 4.